So welcome you all to OpenSCAP community in India, and I would thank Ram again for organizing this beautifully. Okay, so today we're gonna have like particular topics that I'm gonna speak about. Maybe you might have heard of it or maybe checked the agenda before. So how you can enforce supply chain security for Linux distributions. And today we're gonna start from very basic, maybe starting from code to kernel. But before I start, let me tell you, like, we only have 15 minutes, so I will not go much deeper. But after the talk, we can have much more discussions if you want. Okay, so as Ram told, I'm working at Forrester. So yeah, this is Aditya Soni, and currently I'm working as DevOps Engineer 2 at Forrester. Before this, I worked at Red Hat, and I'm one of CNCF ambassador, speaker, mentor, and more. I'm leading a lot of user groups for Rajasthan region in India. So maybe it's AWS or maybe you can come from Asia Crops, CNCF. So I'm leading them. She's my co-speaker Anshika. She's not able to join because some personal issues, but she will be in KubeCon India if many of you coming there. So yep, you can meet and you can discuss a lot of stuff from her. Okay, before we start, let me go through with the roadmap and things we're gonna discuss today. So the first thing, I'm gonna take you with the basic, a quick journey, like how the threat landscape is expanding. Maybe starting from which kind of vulnerabilities we are getting and what had happened in the past, and why we even need supply chain security for Linux distributions. Then we're gonna move ahead with how a secure supply chain looks like. Maybe we can have some pointers that we can discuss later on. And these come with maybe verifying your source, where from your code is coming. Then maybe we can go with the builds, like how the build part is happening. Then we can go with the SBOMs that you have already, Vivek already spoken about that. Then we can take some of the look on the tool side. What are the open source tools that are available for securing supply chain in Linux distributions? Then maybe we can move ahead by the particular step-by-step pipeline that I have created to maybe secure any Linux distributions. So yep, let's start. Okay, so before starting, might be like, I just want to know, like, any of you might have heard a lot of supply chain attacks that might be heard in past. So any of you like remember any names or particular supply chain attacks? Yep. Sonar builds, yeah, that's the famous one, I would say. So, yep, let's go through with them. So, if you see the major supply chain attacks, maybe from starting, it's from the Linux distributions. The first one is XZ utils backdoor, and then we had one of the attack on the Linux OS, and one of that is like Jakarta Stealer in PyPy repository, because once you install any packages in the Linux distributions, so on the time it might impact a lot of things. And then you had some code execution vulnerabilities, or maybe like if you heard about this, I'm not sure. Like, so npm package has some like malicious activity there, and then 8 million downloads was there on that time. Okay, and if you see, like the same npm package had hundreds of developer SSH keys via GitHub. So whatever SSH keys you might have stored in GitHub, that has been stolen from with that. And yeah, then we come to SolarWinds. That's the famous one, I would say, but that's why I kept it at last, because most of you already know this. So that was again, I would say, a Rust nightmare for the cyber attack, and then a good story to read about. Okay, so we all know about all of these attacks, but why these attacks are happening again and again, and what are the mitigations? Okay, so maybe let's come to the why first, and then maybe we can look for the solutions. So if you see, like, these are, maybe we can say, more frequently and impacting a lot of stuffs, but how these are actually coming. So the first one, you can take a reasoning like maybe dependency poisoning. So whatever dependency you are actually installing, or you may be actually taking through your distributions, or maybe Linux system itself, that's having some poisoning, or the packages are having some vulnerabilities. So yep, make sure like those are not, those are having not having any vulnerabilities or CVEs are there. Then we can have some malicious code injection. So might be any developer, like I'm not saying like he might have pushed something, but by default, or maybe he missed something and that has been pushed to your main branch, and then that's what it causing the issues. And maybe you can check about the compromised package managers, because you always not take care of about them. You just write the command, pip install this, pip install that, and everything just come to your hand, and you just run it. But we usually don't verify what version we have installed, this is the latest one, or how the particular vulnerabilities are going there. So that will be other stuff. And blind spots in open source ecosystem. Yep, that's why we all are here. Like, we all are here for open source, and once like a lot of developers working on the same stuff, they do code, but if a single pull request might have merged that's having some issues or some vulnerabilities, that can cause a lot of stuff later on. So those are some reasons, I would say. But if you see this reason, so this can be fit in any area, not on the Linux distributions, but it can be fit in any area. Then you might be having a question in mind, like, why the Linux distributions? Why we need the security, or maybe the supply chain security for those? So if you look around maybe so like closely, so even today, if we are running on any Kubernetes, or we are going for any large-scale AI systems, everything is running on containers, and behind the scenes, it's Linux at the last, right? So the foundation should be strong. So if you are building a home, you always focus on a foundation. If the foundation is not strong and you build the whole app, you are maybe deployed into production, but later on, if things going wrong, then it can cause a lot of like loss to you, okay? So that's why the foundation should be strong, and the foundation is Linux here, okay? So if you're not securing it, maybe you're building on sand. And if we go beyond that, so maybe that you are maybe installing 1,000 of packages, and those packages have their own, I would say, volunteer packages and other similar packages. So once you install a single package, that comes with a lot of different kind of, or I would say, child packages also. And you are not sure like which particular package is having any issues or any vulnerabilities. And particular any weak package can affect the whole system, because you might have all like faced issues with the Apache. If any particular package have any issues, then your whole website can go down in just seconds. Okay, so that's one. And okay, so that was like why you need, and maybe let's come to how you can secure your whole supply chain for the Linux systems. So if I go with that, so the first one is like maybe you can verify your source, where from the code is coming, it's GitHub or where you're storing it, and how you can secure that. So you have to make sure on that. We will discuss more on that. And then you can have reproducible builds. So whatever you're building in one system, that should work in another one. And then we have dependency visibilities. So whatever dependency you have done, so you can generate SBOMs, you can check all of them. And then we have tamper-proof attestation, so you can attach or maybe attest each and every particular versions or the things that you are pushing out. Okay, so first let's start with the verifying source authenticity. So why we are focusing on the source? Because that's where the first commit, or I would say things are happening, okay? So if any developer pushing something, that's going to source, the first thing. Okay, so the first thing you have to focus here is you have to assign commits and releases. So whatever releases you are pushing out, or whatever commits you are doing, you have to sign them, or maybe you can verify or get tags. And for doing so, you can use GPG or Sigstore kind of tools for source validation, okay? Then let's come to the next part, that is reproducible builds. Okay, so you have to ensure the consistency. So let's say there are two developers, the developer A, developer B. Let's say developer A has pushed some code, he has built it in local, and then the build is going on at another environment that can be on cloud or anywhere. So the particular developer A that has pushed something that's working on his particular distribution of the Linux, but at the same time, the same is not working in another distribution. So it would be a major issues later on, because the same code would fail another distribution, or the same package won't work. So no matter like how the code it is, but you have to rebuild any package and get the identical output. Like no matter which distribution running, but the output should be identical. So that first you have to focus on, and then you have to eliminate non-determinism. So basically, even though the systems are the different ones, but you have to look forward like which errors you are getting, and accordingly you have to take the next steps for that. So there are like a couple of tools, but I would suggest like diffscope. So that's good for the comparison for like before you're building or something. So you can just try this out and maybe go with that. Then we have SBOMs. So yep, as you all know, like SBOMs are like the integrants or whatever integrants your software is having that you can check by the software bill of materials. Okay, so you actually check the full inventory, like what kind of tools, what kind of dependency, which versions you have already installed, and if any changes are there, you should always look forward to that. So the tools you can use maybe Swift, Trivi, SPDX, or CycloneDX, and Trivi demo you have just seen by the Vivek slide just before. So why actually you need the SBOM, or why actually you need to know this? Because before even coming to vulnerabilities, you can just let them know. If you like, hope you all remembered about the log4j or other issues have came. But if on the time you might have generated SBOMs and you have looked forward to that, you might not have got them or mitigate them beforehand. Okay, so this is all for like maybe like the 3-step I would say, and maybe let's focus on like what are the open source tools that those are available for maybe looking forward to securing it more. So the first one is Sigstore. So in Sigstore, maybe you can use Cosign for container signing. So as everything is working on microservices, so yep, use Cosign for sign those containers, and Rekor for transparency logs. So what kind of logs you are getting and all. Then you can use in-toto. So what in-toto will do for you, like it will generate some basically the whole step, or I would say for the whole supply chain, it will create the whole steps, and accordingly whenever you are trying to install or trying to follow them steps, so there would be no issues occurring. Then you have OpenSCAP. So OpenSCAP is nothing but it will just help you with the more compliance issues, and it will generate the auditing and security baseline reports, because each and every time you maybe enter a new product or maybe enter a new project, on that time you have to first go with the compliance and all issues. So on that time OpenSCAP can help you a lot. Then we have BuildKit, Bazel, and so these are for the traceability only. So you can maybe go through with them, and maybe I can share you some getting started tutorials if you need. Then we have how you can build a secure distribution for Linux distribution, maybe whole supply chain. So maybe you can start with the source, then you can sign it, like whatever commits or tags you are coming, you have to sign them, and then we have to focus on the reproducible builds. So once build is done, you can focus on the SBOM, like whatever SBOM previously there, so those are changed or not, like how the versions are working for them, or what kind of changes that you might have not pushed, so you can work on that. Then whatever artifacts is created by your whole build, you have to sign again that, because that would help you to more secure the whole pipeline. And once that is stored in the registry, you can deploy and verify it again, like everything is working fine or not. So if maybe you can follow, if you follow like each and every step, if you follow the best practices for even for the Linux distribution, so it would be better for you and you won't get any issues later on. Going forward, like what are the key takeaways, or maybe like if you are building at your own, and maybe if you want to mitigate those issues, so what kind of things that you can focus on. So first thing is like supply chain security is critical but not optimal, so or not optional I would say. So it's not like you can just ignore these things on the baseline itself or the foundation itself, because that would be more critical for you. And the earlier you start, the early you will like mitigate a lot of issues with the help of maybe source verifications or SBOMs. And there are tons of open source tools available, and in open source landscape also you can find some. So I would suggest like maybe go with them, Sigstore, in-toto, and like take help with them. Okay, and be proactive, not reactive, because if you will be awake before the incident, that would be better for you. And the last take I would say is like, if there's one thing to remember about like maybe securing any Linux distributions, then it is security is no longer an afterthought. It starts from the first commit. So whatever coming from the source code, or I would say whatever coming from the first commit to the source, that should be secured, and you have to look again and afterwards, like each and every time from that thought. So yep. That's all, and we can connect on LinkedIn. You can maybe just scan it, and we can discuss more on the after this. Thank you so much.